The universe is unimaginably vast, not metaphorically vast, not poetically vast, but mathematically overwhelming. There are billions of galaxies, each containing billions of stars. Around many of those stars orbit planets, rocky worlds, gas giants, frozen spheres drifting in darkness. By every astronomical measure, the cosmos is crowded with possibility. So where is everyone? This question lingers like a quiet disturbance beneath every discovery. The numbers suggest abundance. The silence suggests absence. We point our instruments toward distant systems. We scan for patterns in radio waves. We analyze atmospheres for chemical signatures. And still, nothing speaks back. No signals, no artifact, no undeniable proof that somewhere else intelligence has awakened and begun to wonder. The emotional contrast is difficult to ignore. On one side, scale beyond comprehension. On the other, a sky that remains perfectly mute. It feels statistically unreasonable. With so many stars and so many planets, life should not be a miracle. Intelligence should not be singular. Given enough trials, nature tends to repeat itself, at least. That is what we assume. We assume that where conditions resemble Earth, life will follow. We assume that given enough time, simple organisms will climb toward complexity. We assume that intelligence is a natural endpoint of evolution, a predictable outcome once chemistry begins to stir. Add enough planets, multiply enough probabilities, and the conclusion feels unavoidable. We should not be alone unless the math is misleading. Unless we are quietly multiplying uncertainties without noticing how fragile each step truly is. Perhaps the problem is not that civilizations are too distant to reach us. Perhaps it is not that signals fade before crossing the void. Perhaps the real issue lies much deeper, hidden inside the probabilities we take for granted. What if intelligence itself is the rarest accident in the universe? At first glance, the numbers feel reassuring. Our galaxy alone contains hundreds of billions of stars. Beyond it stretch billions of other galaxies, each with their own stellar populations, their own planetary systems, their own chemical histories, unfolding over cosmic time. Modern astronomy has confirmed what once was speculation. Planets are common. Trillions of them likely orbit stars across the observable universe. From this perspective, the conclusion seems obvious. If even a tiny fraction of those planets resemble Earth, and even a smaller fraction of those develop life, then the sheer scale should compensate for rarity, multiply small probabilities by enormous numbers, and the result should still be abundance. This is the intuitive leap. More planets must mean more life. Scientists have long tried to formalize this reasoning, break the problem into steps. How many stars form each year? How many have planets? How many planets lie in habitable zones? Of those, how many develop life? Of those, how many evolve intelligence? The logic feels clean, almost mechanical. Even if each fraction is modest, the multiplication across billions of opportunities seems to guarantee success somewhere. There is comfort in this structure. It transforms mystery into arithmetic. It suggests that the universe operates like a vast statistical engine, steadily producing civilizations as a natural output of cosmic abundance. The bigger the universe, the safer the assumption. But this comfort hides a subtle instability. Each step in that chain is not a certainty, but a condition. A planet must not only exist, but remain stable for billions of years. Life must not only begin, but survive catastrophic resets. Complexity must not only emerge, but avoid evolutionary dead end. Intelligence must not only appear, but persist long enough to develop technology. And each of these steps does not merely add uncertainty, it multiplies it. If any one factor is extraordinarily rare, the entire product collapses. A single unlikely transition can shrink billions of opportunities into near zero. The seductive math of big numbers begins to wobble under the weight of compounded improbabilities. A big universe does not guarantee intelligent life. It only guarantees many attempts, and attempts are not the same as outcomes. And that's when the real problem begins. Before we even speak about intelligence, we have to confront a quieter miracle, life itself. Not complex life, not thinking life, just chemistry that refuses to remain chemistry. The conditions required are narrower than we once imagined. A star must burn steadily without violent fluctuation. A planet must orbit at a distance where water can remain liquid, not frozen solid or boiled into space. Its axis must remain relatively stable. Its atmosphere must neither vanish nor become toxic beyond repair. Even then, the ingredients must assemble into something self-replicating. Molecules must organize, store information, and reproduce with variation. That transition from inert chemistry to the first living cell may have happened quickly on Earth, but quickly does not mean easily. We have no evidence of it happening twice, even here. And once life begins, survival is not guaranteed. It requires time, billions of years of relative stability. Yet Earth's history is anything but calm. Asteroid impacts, supervolcanoes, ice ages that nearly froze the oceans, mass extinctions that erased dominant species in geological instants. At least 5 times, complex ecosystems were reset, as if evolution's progress had been wiped nearly clean. Life persisted, but persistence is not progress. For most of Earth's history, life remained simple. Single-celled organisms dominated the planet for over 2 billion years. The leap from single-celled to multi-celled life was not inevitable. It required cooperation between cells, specialization, coordination. It required a new level of biological organization that might never have emerged. Then came nervous system structures capable of processing information. Another bottleneck, another improbable escalation. And beyond that, consciousness, awareness not just of environment, but of self. The ability to reflect, to imagine, to plan. Each transition narrows the path. Evolution does not move upward by default. It explores sideways, branching into countless forms that succeed without becoming complex. Sharks thrived for hundreds of millions of years without building civilizations. Bacteria remain among the most successful life forms on Earth. Intelligence is not the dominant strategy, survival is. When we look back at our own history, it is tempting to see inevitability, but that perspective hides the fragility beneath it. A slightly larger asteroid, a slightly unstable climate, a different mutation at a critical moment, and the chain could have broken. The mammals that eventually gave rise to humans only flourished because dinosaurs disappeared. Our existence depends on catastrophe. We survived a sequence of near erasures, a chain of unlikely survivals stacked across deep time, and this realization forces a shift in perspective. The question is no longer simply how often life appears. It becomes far more specific and far more unsettling. How often does life cross all these bottlenecks and become intelligent life? There's a quiet assumption hiding beneath most discussions about extraterrestrial life, that evolution naturally trends toward intelligence. Given enough time, we imagine life climbs from simple to complex, from instinct to awareness, from awareness to technology. Intelligence feels like the summit of biological development, as if nature were slowly working its way upward. But evolution does not select for intelligence. It selects for survival. On Earth, the overwhelming majority of living organisms are not intelligent in any human sense. Bacteria, insects, plants, fungi, these forms dominate in number, resilience, and longevity. They do not contemplate the cosmos. They do not build machines, yet they thrive. They adapt, they endure. In evolutionary terms, they are extraordinarily successful. Intelligence, by contrast, is expensive. Brains consume enormous amounts of energy. In humans, the brain accounts for a small fraction of body weight, yet devours a disproportionate share of calories. Maintaining complex neural structures requires stable environments and reliable resources. Intelligence also introduces risk. Curiosity leads to exploration. Exploration leads to danger. Technology amplifies both power and vulnerability. For hundreds of millions of years, dinosaurs ruled this planet without developing radio telescopes or mathematics. They were exquisitely adapted to their environments. They dominated ecosystems across continents. From evolution's perspective, they had no need for abstract reasoning or self-awareness. Survival did not demand it. This challenges the comforting narrative that intelligence is the inevitable flowering of life. Nature does not aim upward. It does not pursue progress in any conscious sense. It operates through variation and selection, blind to future possibilities. Traits persist because they work in the present, not because they promise cosmic significance. In this light, intelligence begins to look less like a destination and more like a rare side effect. A peculiar configuration of neurons that happen to offer short-term advantages under very specific conditions. Remove those conditions and the trajectory could shift entirely. On another world, evolution might favor resilience or speed or camouflage without ever crossing into reflective awareness. The common belief is that given enough planets and enough time, intelligence must arise repeatedly. But reality offers a harsher possibility. Intelligence may not be a convergent outcome at all. It may be an accident layered upon earlier accidents, contingent on fragile environmental and biological coincidences. If that is true, then the silence of the universe becomes less surprising. A big cosmos does not guarantee thinking observers. It only guarantees experiments, and even if intelligence appears, something else may erase it. The universe may be filled with life, but intelligent life faces a peril far beyond mere rarity, the great filter. This concept suggests that at some stage in the development of life, there exists a barrier so formidable that almost no civilization passes it. It is a question of surviving long enough to persist, to advance, to leave any trace at all. Civilizations, even after achieving intelligence, are perilously vulnerable. The stage we call technological adolescence is fraught with existential hazard. The very tools that allow advancement, energy production, global communication, powerful algorithms carry the seeds of potential destruction. Nuclear weapons can annihilate cities in an instant. Artificial intelligence, if mismanaged, could outpace understanding before it can be contained. Environmental collapse, driven by unchecked growth and resource exploitation, threatens to reverse millennia of progress in decades. Each new capability magnifies the stakes. This is why the silence of the cosmos carries such weight. It is easy to imagine civilizations spreading across the stars, broadcasting signals, building empires, but the evidence is absent. Perhaps the filter lies not in the distance between us, but in the vulnerabilities intrinsic to life itself. Here lies the terrifying duality. The filter may be behind us, already crossed. Humanity might be one of the few, or the only, civilization lucky enough to navigate all prior bottlenecks, emerging from the fragility of life, the randomness of evolution, and the improbable spark of intelligence. Or the filter may be ahead of us, a future yet unseen, waiting to test whether our species can survive the very powers it has unleashed. The emotional weight of this possibility is profound. To consider that the universe might be full of civilizations that failed at precisely this stage is to confront the fragility of our own existence. We are not only rare, we are vulnerable. Every decision, every invention, every experiment carries potential consequences that could close the path forever. Understanding the great filter reframes the cosmic silence. It is not merely emptiness we face. It may be the aftermath of countless civilizations that never survived their adolescence. The absence of signals could be evidence of failure writ across the stars. What if the silence we observe is not absence, but aftermath? For decades, humanity has listened. Radio telescopes sweep the heavens, scanning for patterns, signals, anything that might betray the presence of a distant intelligence. The search has become more sophisticated over time, from crude attempts to detect radio waves in the 1960s to the precise, wide-ranging surveys of today. Every ping, every pulse, every faint flicker in the darkness is cataloged, analyzed, and yet the universe remains mute. No confirmed signals have arrived, no alien broadcasts, no technological signatures, no traces of civilizations reaching across the void. Despite the statistical likelihood suggested by trillions of stars and planets, the cosmos offers only silence in response to our persistent questions. It is not an empty universe that startles us. It is a quiet one, a universe that refuses to answer. But silence is not nothing. In the language of the cosmos, absence can speak louder than presence. Every unanswered signal is data. Every void, every quiet region of space informs our understanding of possibility. What we do not see constrains what can exist. The lack of evidence becomes evidence of lack, at least for civilizations capable of sending detectable signals. This realization forces a psychological shift. Perhaps the very rarity of intelligent life is the point. Perhaps life does not proliferate across the stars in neat, predictable patterns. Perhaps the universe is a place where intelligence is not the default outcome, but an extraordinary exception, a fleeting anomaly among countless failed experiments. The vast emptiness of space is not merely a stage. It is a measure of probability, of fragility, of the extraordinary circumstances required for intelligence to emerge and endure. And yet, there is a strange beauty in this emptiness. It underscores the uniqueness of our own existence, the preciousness of consciousness and self-awareness in a cosmos that rarely permits it. Our silence becomes a mirror, reflecting not only what is absent, but what is improbable. Each quiet star, each darkened galaxy, reinforces the delicate balance that allowed life and eventually intelligence to arise here on our small blue world. The silence of the sky is both a warning and a lesson. It challenges us to reconsider assumptions about inevitability, about abundance, about the destiny of life in the universe. It forces a confrontation with our own fragility, and yet it also invites reflection on significance. If intelligent life is so rare, then its emergence carries weight, purpose, and responsibility. And in facing this cosmic quiet, we begin to shift from the empirical to the philosophical, pondering not just the mechanics of life, but the meaning of existence in a universe that speaks in absence rather than presence. Richard Feynman approached the universe with a rare combination of curiosity and humility. He marveled at nature's complexity, Yet he never assumed that its patterns conformed to human expectation. Where others might see inevitability, Feynman saw contingency. Where others might weave narratives of cosmic destiny, he insisted on careful calculation and honest appraisal of uncertainty. His perspective reminds us that even the most elegant reasoning must bow to the stubbornness of reality. One of Feynman's most enduring lessons was the danger of assumption stacking. It is all too easy to chain one optimistic guess onto another, creating a delicate edifice of probability that appears convincing on the surface, but crumbles under scrutiny. We expect this, therefore that, therefore something else, and suddenly the argument feels airtight. Feynman cautioned against such comfort. Every step in reasoning, he argued, carries risk. Each layer of assumption compounds uncertainty, and the universe does not grant exceptions for wishful thinking. Probability, not imagination, was Feynman's guiding principle. He acknowledged that our intuitions often fail us, that the human mind seeks patterns where none exist. To navigate a cosmos of vast scale and unknowable conditions, we must weigh likelihoods carefully, not rely on the seductive simplicity of expectation. Even phenomena that seem inevitable in retrospect may be the product of improbable accidents, fortuitous timing, or sheer luck. This lens reframes the cosmic silence. Nature is not obligated to repeat miracles. Life on Earth may be an extraordinary confluence of events, a series of coincidences stacked just right to produce intelligence. To assume that such a sequence will naturally recur elsewhere is to ignore the subtle, fragile contingencies that Feynman insisted we respect. Every planetary system, every evolutionary trajectory, every moment of survival is provisional. We are observers in a universe that does not owe us repetition. Through Feynman's perspective, our apparent uniqueness is neither arrogant nor comforting. It is factual. We may be extraordinarily lucky to have passed the fragile bottlenecks of life, evolution, and intelligence. Our existence is a testament to improbable chains of survival, each step a quiet rebellion against the forces of chance. Recognizing this does not diminish our significance. It amplifies it. As we reflect on this skepticism, we begin to move beyond statistics and biology into existential territory. If our intelligence is rare, if the cosmos rarely grants the opportunity to observe itself, then each conscious life carries weight, responsibility, and meaning. The lens of Feynman transforms uncertainty into awareness, reminding us that the rarity of intelligence is not just a mathematical outcome. It is a profound invitation to understand our place in the universe. If intelligent life is truly rare, then our existence carries a weight far beyond what we usually consider. We are not simply another form of life on a common planet. We are a singular outcome of a chain of improbable events that stretched across billions of years. Every decision, every scientific breakthrough, every effort to understand the cosmos becomes amplified in significance. The rarity of intelligence transforms our presence from ordinary to exceptional. With this rarity comes responsibility. To exist is not merely to survive. It is to acknowledge the fragility of consciousness itself. Every action we take on our planet toward the environment, toward knowledge, toward each other affects the probability of maintaining the delicate conditions that allowed intelligence to emerge. To squander this opportunity would be to ignore the extraordinary circumstances that brought us into being. We become caretakers not only of our world, but of a rare spark in the vast darkness of the universe. Loneliness in this context shifts meaning. Silence in the heavens is no longer merely absence. It is evidence of uniqueness. Every star that remains dark, every galaxy that does not broadcast a signal, underscores the improbable miracle of intelligent life on Earth. Our isolation becomes a marker of significance. The cosmic quiet transforms from a source of despair into a mirror reflecting our extraordinary existence. And yet, this recognition is not bleak, it is profound. The stars remain silent, not because they are empty, not because the universe has failed to produce life, but because intelligence may be the rarest cosmic event of all. Our awareness, our curiosity, our capacity to question and reflect are gifts that are far from guaranteed. Across trillions of worlds and billions of years, few may have attained this level of self-consciousness, and even fewer may have endured long enough to ponder their own existence. In this light, every thought, every discovery, every attempt to reach beyond ourselves takes on heightened meaning. We are living proof that the improbable can happen, that fragile chains of events can align to produce understanding, reflection, and wonder. The universe is not indifferent in its scale alone. It is astonishing in its selectivity. The universe is vast, but rarity does not contradict vastness.